So by now you should be fairly proficient at taking a binomial and multiplying it by another binomial. And just as a quick example, let's say x plus 2 times x plus 3. If we were to expand and simplify this, we would use our FOIL, or we would say distributive property. Either way, we're going to go x times x to give me x squared, x times 3 to give me 3x, x times 3 to give me 3x, 2 times x to give me 2x, and 2 times 3 to give me 6. And I would combine my like terms. I would say x squared plus 5x plus 6, and that would be expanded. Now, going from binomial to a polynomial, this is expansion. Today, we're going to look at, just take out some extra lines here. We're going to look at going from this polynomial to this. And this is no different than saying, okay, if we have the number 24, 24 could be represented as 6 times 4, and we call these things factors. So if I'm working from here to here, I'm factoring. Same here. If I have this polynomial, and I'm going back to what it was before we multiplied it out, it's called factoring. So we're going to look at factoring today. And there's lots of little details within factoring that you really need to pay attention to and get into your tool belt so that you have that information to work with. So polynomial in the form of x squared plus bx plus c. This is just a fancy way to write out any general polynomial in which we have a coefficient in front of an x term and we have some kind of constant. And these are two numbers. And if I go over to my example, in this case over here, the x squared plus 5x plus 6, 5 would be my b, 6 would be my c. Okay? So they're just constants or numbers, coefficient and a constant. And we need to work with that information and factor. Now, if we're using algebra tiles, we find our set of algebra tiles with respect to whatever this polynomial happens to be. And in this case, let's assume that these are all positive tiles. This would be an x squared. This would be an x, and x, and x, and x, and x. And these would all be 1s. So this polynomial would be x squared plus 5x plus 4. So we have our set of algebra tiles. What we want to do with those algebra tiles is rearrange these tiles to form a nice rectangle. And I'm going to do that inside our little square, or inside our little box here. So I'm going to take my tiles and I'm going to go 1, there's my x squared, and I'm going to go like this. Here's my 1 rectangle. 2, 3, 4, put another rectangle here, and then my 4 squares. 1, 2, 3, 4. Now I show spaces here because that's generally how we kind of write them. That's generally how you might see them. But what really ends up happening is that we end up, if we squish all those spaces out of there, we end up with a rectangle in which we have our one big square. We have our x there. 1, 2, 3, 4, and 4 little squares. So there's our big x squared. Here's our 1, 2, 3, 4, 5 x's and our 1, 2, 3, 4 1s. So you can see how that's semi-represented right here. So now I look at the dimensions of that rectangle. Well, what does this dimension represent? Represents an x. Each of these edges of these rectangles represent 1s, so this would be a 4. Everything that we're dealing with is positive, so this would be x plus 4. This dimension represents x. This dimension represents 1. This would be x plus 1. So my factors are going to be x plus 4 and x plus 1. That's how we can use Algebra Tiles to factor polynomials. Now, we're going to get a little bit of practice at doing that, and like I said before, you need to be proficient. Well, you don't need to be super proficient at using the Algebra Tiles, but you do need to understand how they work. So we will play with that a little bit in class if we haven't already. Another way to look at factoring is to look at this table. It says use a table or chart to factor. So I think to myself, okay, so I use this table. What I want to do is find two integers with one, a product, which means you multiply them together, product of 4 in this case, and those same two numbers have a sum, which is addition, of 5. And where does that 4 and 5 come from? Well, that 4 and 5 comes from x squared plus x plus 4. That 4 and 5 come from this 4 and this 5. Okay? Product of 4, sum of 5. And where did those come from? If I go back to that example we looked at the beginning, way up here, when I expand this polynomial, of x plus 2 and x plus 3, to get this last term, where does that come from? It actually comes from the multiplication of 2 and 3. Where does this 5 come from? It comes from the sum of the two middle parts, the sum of these two numbers. Okay, so when we're looking at factoring polynomials and using a table, in this case, because this is my polynomial, I'm looking for two numbers that multiply together to give 4 and add together to give 5. And I start with the factors of 4. So in this case, I want to start with the factors of 4. Well, what are the factors of 4? 1 and 4, or 2 and 2. Simply, right? So we were listing out factors the other day. 1 and 4, 2 and 2, there are my factors. So if I had the factors, if I use the numbers 1 and 4, well, what's that product? That product together, 1 times 4, 1 times 4, 1 times 4, well, that equals 4. 2 times 2, well, that equals 4 as well. Well, what about the sum? 1 plus 4 is equal to 5. 2 plus 2 is equal to 4. Well, this one does not give me the numbers that I need here, so it can't be this. It can't be 2 and 2. So it has to be 1 and 4. So now that I've found my integers, my integers are 1 and 4. Then I just simply write out my binomial brackets. In this case, x plus 1 and plus 4. Now that I've factored that, a very quick check, and I would suggest doing this every now and then to make sure you're on the right track. X plus 1, x plus 4, because you've had lots of practice at it by now, you should be very able to and very quickly be able to go x times 4, 1 times x, 1 times 4, expand this out to get x squared plus 4x plus 1x plus 4, or x squared plus 5x plus 4. Expand that out and simply check to make sure that that's where you needed to end up with, which is what I started with. Okay. Factoring using a table, factoring using Algebra Tiles.